All right, today we are starting the section where we will be solving equations that look like this. They're called rational equations, and they're rational just means fraction. Equations that have pretty major fractions in them. So we're doing this in two steps, and the first step is finding a common denominator. So what we're going to do is get a common denominator for all the terms. So I'm going to go through the process of finding a common denominator, how I go about doing it, and then after that, the solving is just solving like we've been doing, okay? So the idea here is the first thing you want to do is factor denominators. So we're going to factor the denominators completely. So here, x plus 1 is factored already. There's no GCF. There's none of that garbage. So is x minus 3. And then this one isn't, so I'm going to factor that. So we'll do our AC method. I don't know if I'll do that for every one, but here we are. So we have negative 3, two numbers that multiply to negative 3 and add to negative 2. There would be negative 3 and a positive 1. So do grouping, so we factor out an x, factor out a 1, and it's x minus 3, x plus 1. Okay? Then, so I'm going to just make this a little bit neater for me, and I'm just going to, it's x minus 3, this is x minus 3, and x plus 1. Please note, it does often happen that it's like that. Okay, so I usually put a little CD for common denominator over in the side here because most of my work is below. And then I look at each term. I look at the bottom of each term, the denominator. And I say, okay, x plus 1 is a factor. So a common denominator is going to have that x plus 1. X minus 3 is a factor. A common denominator is going to have that x minus 3. X minus 3 is a factor. We already have it. And x plus 1 is a factor. We already have it. So that's literally what you want to go through. Just look at each one and make sure that there's a common denominator, or each of the factors in that one is in the common denominator. Then what we do is we multiply the top and the bottom of each fraction. So we have 1, 2, of each fraction, the 3 fractions here, and we multiply the top and the bottom by what it's missing from the common denominator. So this one has an x minus 1, so it does not need an x plus 1. Excuse me. This one needs the x minus 3, so I multiply the top. This is a little messy. Maybe I should rewrite this, but whatever. Multiply the top and the bottom by the x minus 3. This one here has an x minus 3. It needs the x plus 1. So I multiply the top and the bottom by x plus 1. This one here has an x minus 3. It has an x plus 1, so it doesn't need anything. All that it needs... All right, so what we have here is, I'm going to rewrite this so you can see what it is. I have x minus 3 times 1 on the top, and I have x minus 3 times x plus 1 on the bottom. This one, I have x times x plus 1 on the top, and I have x minus 3 times x plus 1 on the bottom. And then this one, I have, it doesn't change. Okay? What actually happens now, that is the first milestone. The second one is when all the denominators are the same. All we need to do is write the numerators. So this being the first step, the equation is going to be x minus 3 plus x times x plus 1 equals 4x. So it's basically just the tops. So the purpose, if we get all the bottoms the same, all we have to do is get all the tops the same, and that's how we do it. All right, so I'm going to go a little faster for this one. And then find GCF is the second step. the GCF. Greatest common, I don't even know what I'm even thinking here. Find common denominator. It doesn't have to be a least common denominator. That's what I was thinking in my head. And then the third thing is give each fraction what they are missing. Okay, so I'll try to do this one. The space here isn't great, so I'm just going to write my common denominator here for this one. So this one is, the first one is factored. Remember, we only look at the bottom. We have to factor this one. This is dots. X plus 5, x minus 5. And then 1, it's not a fraction, so I make it a fraction, 1 over 1. So the common denominator here is this x plus 5 is a factor. This one already has an x plus 5, and this one has an extra x minus 5. This one is 1, so 1 we don't really count. It's just 1. You can put a 1 there, but it doesn't change anything. So now what we have to do is we have to multiply the top and the bottom by what's missing. Now what I like to do when I have one like this, and I know that I'm going to be multiplying by both of them over here, I say to myself, well, x plus 5, x minus 5 is the same as x squared minus 25. These are the same. One is factored and one isn't. Okay, so I'm going to just rewrite this real quick. So, with a little space. So x plus 2 over x plus 5 is the first one. And 1 over 1. So when we multiply, x plus 5 is in the common denominator. It needs an x minus 5. So I multiply the top and the bottom by x minus 5. This one over here, x minus 5, that is the common denominator. It doesn't need anything. This one here doesn't have either, so it needs both. And if it needs both, I use the one where it's already multiplied together so that I don't have to multiply later, because why would I want to do that? Okay, so this is really where we're going to go. Once they're all the same, we're going to cross these out, and we're going to have x minus 5, x plus 2. That's just this part, plus x minus 1 equals x squared minus 25, and then we're going to solve that. Okay, I don't know if I'm going to do all of these. This is my first time doing this like this, so I think I have way too many here. So let me just run through it, but I don't know. We'll find the common denominator. I'll do it fast. Okay, these three are all factored already. There's nothing to factor with these three, so I'm just going to go through each. X plus 10, that's in that denominator. 5, this one is x plus 10, and I already have it. So that's my common denominator. I just simply have to multiply the top and the bottom by what's missing. This one isn't too messy, so I can just kind of write. So this one has an x minus 10, or x plus 10, excuse me. It needs the 5. This one has the 5. It needs the x plus 10. This is messy. I apologize. And this one has an x plus 10, so it needs the 5. So I'll just rewrite this so you can see it a little clearer. So it's 5 on the top and 5 times x plus 10 on the bottom, plus 1 times x plus 10 on the top, 5 times, x plus 10, that's this one right here. And then the last one is 15, because I can just do that, and 5 times x plus 10. So when the equation is going to be, and you're just going to solve it, and that'll help you find x. Okay, so let's do it with this one, same idea. Already factored already, always nice. So x minus 3 is a factor, x is a factor. Okay, x is its own factor, you can't subtract or anything, so it's just like a 5. Okay, you just have to put it in your common denominator. So this one needs an x. This one needs an x minus 3. and this one needs just an x. So when I rewrite this one, it's x squared on the top, x times x minus 3 on the bottom, minus, notice the minus there, 4 times x minus 3, and the last one is 3x, x times x minus 3. When you're done here, the bottom should all be the same. Just remember this sign. And that's it. Okay? Anything like this, I do want to just make sure you should factor these so you can just see them. So this, I'm going to factor it and rewrite it. So this first one is 2 times x plus 3. This is a GCF factoring. 1 over 2 times x minus 3. And this one is 4 over x plus 3, x minus 3. So this was dots. Okay, so when you're finding the common denominator here, we need a 2 and an x plus 3. The first one is just rewrite the first one because it's always like this one. This one has a 2 already. We already have the 2, but it needs an x minus 3. And this one has an x plus 3 and an x minus 3. We have that already. So when you go through it, that's the process you want to go through. So what's missing in these guys? So let's switch to this color. So this one has a 2 and an x minus 3, or x plus 3, excuse me, so it needs the x minus 3. This one has a 2 and an x minus 3, it needs the x plus 3. So this is all we're going to practice, and this one has an x plus 3 minus 3, but it needs the 2. And finally, just rewrite it without 1 times, I guess we could, and equals 8. All right, I'm not going to do this one. It's the same as this one, so we'll just stop there. All right, you have a great day. I hope you understand. We'll practice again later.